Welcome. This is Chapter 5, Homework 2. Now let's take a look. This states the triangle inequality theorem, and it looks like that is the title for all of these questions, 1 through 18. So I think it would be important to just write out the triangle inequality theorem. And it looks something like this. So the triangle inequality theorem states that if you order the sides least to greatest, you'll call the smallest one S1, S2, and S3. Now we saw in class, you may have a tie, and that's okay, then the order doesn't matter. So if S1 and S2 are both 3, and S3 is the number 5, you've still ordered them least to greatest. Then you want to place them in the formula. If I add the two smaller sides together, right? And it has to fit between, the third side has to fit between if you added the two smaller ones or if you subtracted the two. So you could think of it as if I add the two sides, it's going to go, let me see if you can see my splat. The two sides are going to try to make a triangle, splat. If I subtract the two sides are laying on top of each other and they're making just a tiny little triangle, and eventually they go squish. So this formula works really well to help you determine the third side. So if I look down here, this is when I'm going to actually determine the third side. Here, I'm going to check to see if the third side is correct. So maybe the best way to start the homework, of course, is with our formula. And I'm actually going to do this on another piece of paper and then just staple it to turn it in. But you probably could fit your work on here too. That's okay. So there's my formula. And again, my first step has to be ordering the sides least to greatest. So let's just kind of look over. It looks like I could reorder this one 4, 5, 7, 2, 4, 5. That one was fine. That one was fine how it was. Okay, so there's an example where we have a triangle, so that maybe this triangle would look like that. And so we're going to double check to make sure that this would be a possible triangle. But I'm thinking it is because 2 plus 8 is 10, and 8 minus 2 is 6. 8 minus 2 is 6. 8 plus 2 is 10. So does the 8 fit between 6 and 10? Yes. And that's how we're going to use the formula. Okay? And so that's why this picture actually looks pretty accurate. Now, technically you could use construction to do this, but the theorem states you could use this formula. Okay, so let's finish ordering them least to greatest. Nothing too technical here. And again, the challenge here is they're really just asking to state if these can be possible sides of a triangle. So they're looking for a yes or no answer. But the problem is that would be really easy to copy off of someone's paper. So we want to make sure you show all your work for me so I know you know how to answer these questions on a test or on the EOC. Okay, so I got another isosceles triangle. Now, let's go for it. On my other piece of paper, I'm going to just show my work. So side 2 minus side 1. And you can write this formula out as many times as you need to memorize it. Again, that's what homework is for, to kind of reiterate this, because this formula is not provided on a test. So if I take this side 2 and side 1 and subtract, and I take side 2 and side 1 and add, the third side has to fall between 1 and 9. And I can say, yes, 7. 7 is between 1 and 9. Awesome. Okay, so I think that makes sense. We can kind of speed this up because this is going to get pretty redundant. If I add, again, so maybe it makes sense to cover up that third side. If I add the two smaller sides, 4 plus 2, or if I subtract them, 4 minus 2, I have to ask myself, does the number 5 fit between there? And the answer would be yes, it does. The number 5 fits between 2 and 6. Next question. Okay, question 3. I'm going to hide this one. So I have 6 minus 5 and 6 plus 5. So I have to ask myself, does my third side fit between 1 and 11? 9, okay. So I'm going to say yes, it does. The number 9 fits between 1 and 11. Okay, covering up my third side, I got 7 minus 4 and 7 plus 4. Then I have to say, does the number 8 fit between 3 and 11? Yes, it does. Okay. Oh, I just noticed something. Sorry about that. I'm kind of going out of order. I'm going 1, 3, 5, 7. So let me fix that. 1, 3, 5, 7, 9. Okay. Sorry about that. So it's okay to just do these. This works better with my tripod is why I'm going down this way. Okay, so question number 9, hiding this, does 8 minus 3 fit between 8 plus 3? So I'd get, does the number 10, wow, we get a lot of yeses here. The number 10, yes it does. The number 10 does fit between the number 5 and 11. Okay, looking good. And so let's keep going here. If I cover this up, so now I have question 2. If I cover this up, does 3 minus 2 make an inequality? 3 plus 2. So does the third side fit between 1 and 5? No. 6 isn't between 1 and 5. Cool. Question 4. We did this one already, but it'd be a good check. 8 minus 2 and 8 plus 2. So that'd be 10. The third side, does it fit between 6 and 10? And our third side is the number 8. So that's yes, it does. The number 8 does fit between 6 and 10. Question 6, we have 5 minus 4 and 5 plus 4. So does the number 8 fit between 1 and 9? Yes, it does. All right, 9 and 11. So I have 11 minus 9 to find my third side, and 11 plus 9. I think a couple classes we did this question in class. We asked ourselves, does the number 12 fit between 2 and 20? And that would be yes, it does. Okay, so this one's already in order, least to greatest. Question number 10. So we have 13 minus 1 and 13 plus 1. So we have to ask, does the number 13 fall between 12 and 14? And the answer is yes, it does. Okay, ordering least to greatest, I'll cover up the third. So we have 10 minus 10 is 0. And the third side, 10 plus 10. So our third side is 18. Does the number 18 fit between 0 and 20? And yeah, it does. Awesome. Check out the next video for the solutions to these questions. Thanks for joining us.